Problem number 03 in the free response questions. Problem 3 is always going to be sinusoidal, and pretty much every single practice test I've seen has a picture that looks just like this. So whether you're going to be given a problem about a Ferris wheel or a grandfather clock or a pendulum or something swinging back and forth or bouncing up and down, you're probably going to see a problem that is sinusoidal. So let's talk about these two wonderful people, Dr. Chuckles McLaughlin and Congresswoman Penny Prankster. I think I voted for her. I don't know. She's not doing her job. They're enjoying a ride on a Ferris wheel with a radius of 30 feet. The bottom gondola, which these are called gondolas, the bottom gondola is positioned 3 feet above the ground and rotates clockwise once every 45 seconds. All right. So let's pause right there. You got yourself a circle. You got yourself a radius of 30. You got yourself the fact that this is 3 feet off the ground, which means if I were to label these, which I'm going to do in a moment, you know that you're going to be 3 and you're going to be 30 more than that, and you're going to be 30 more than that. Okay, so that's the information that I have so far when it comes to height. Okay, what else do I know? Well, it rotates clockwise every 45 seconds. So these guys are going to be, perfect line, Mr. Parrish. These lines are going to be 45 seconds apart, or these dots, A and E, are going to be 45 seconds apart. So this is going to go around 45 seconds later. So that's our period right there. So let's erase that ugly looking picture, and let's erase that because I'm not happy with it. We'll probably draw something similar again. The Ferris wheel starts its rotation cycle when Chuckles and Penny board the indicated gondola. So right there. It also said it went clockwise, which tells us if something is going to start there and go clockwise, start at the middle and go clockwise up and to the right. It's going to be a sign, but we're not there yet. And by it's going to be a sign, it's going to be a sign and not it's going to be a sign. Okay. I saw one of those and it opened up my eyes. It's a base. The height of the Ferris wheel, h, is modeled by the sinusoidal equation h of t after t minutes. Great. The graph of h and its dashed midline for 2 full cycles are shown. 5 points A, B, C, and E are labeled on the graph. No scale is indicated. No axes are presented. Determine the possible coordinates of the 5 points A, B, C, D, and E. All right, so issue number one. We start right here, but that's not one of our points. But am I going to let that stop me? No, sir. No, ma'am. So I'm just going to say that if this is the beginning of our ride, we have time 0 at the height of 33. Now, if the period is 45, that means every time I hit a maximum back to midline, minimum, and back to the original is going to be 45 divided by 4. Okay, every middle, top to middle to bottom, every time I hit one of these 4 things is going to happen at 45 over 4 seconds later, and 45 over 4 is 11.25. So why does that matter to me? Well, that means the time for A is going to be 11.25. The time for B is going to be 11.25 more than that, so 22.5. The time for C is going to be 33.75. The time for D is going to be 45, which makes sense. And the time for E is going to be 11 more than that, which is going to be 46.25. Okay. Now the heights for these guys are obvious. 63, back down to 33, back down to 3, back up to 33, and back up to 63. So there's technically, since it doesn't tell me how many cycles are done in a cycle or whatever in a ride, I have an infinite amount of answers. But the obvious ones for me are the ones that start out at A, so 11.25, 63, B, which is 22.5, 33, C, which is 33.75, regular 3, D, which is 45 seconds, 33 at height, and E, which is 50. Oh, close one. That was a close one. 56.2563. All right. So, like I said, in pretty much every single practice test that I have taken that has free response questions, problem 3 is very, 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 very similar. And we answered these. Whether that gives you some kind of different sinusoidal thing, whatever, that's what we came up with. Now, part B is giving us all the same exact information, but asking us to write out the formula. Now, let's take a look at the information that we have. Whenever you are given a circular thing and you're given a radius, that is your amplitude. Your amplitude is always going to be the radius. So the radius is 30 because it goes 30 up that way, 30 down that way. Okay. Which, by the way, since this happens 3 feet off the ground, 33 is going to be my midline. So let's write that down here conveniently several spaces away. Okay. Now, we said that the period is 45. If this is a sine function, I need to find B, which is the frequency. The frequency for a sine or cosine function is 2 pi over the period that you came up with, which is 45, which I can't simplify that, so we'll leave that as 2 pi over 45. Don't know why I rewrote it, but I did. Now, since we started this at sine, since this starts here, right, and goes up and then down and then up and down. Remember, it starts here and then goes up and then down and then up and then down. We start where sine is supposed to start, just shifted up 33. Okay, just shifted up 33. So what is my vertical or horizontal shift? Well, I don't have one. There is no horizontal shift. Now, putting this in order, right, gives me my A, B, C, and D. So my amplitude is going to be 30, which means A is 30. B is my frequency, which is 2 pi over 45, me writing it out the third time. I don't have a horizontal shift, so C is nothing. And my midline is 33, so D equals 33, thus completing part B of our sinusoidal example. Now, this guy is typical of what you can expect to see for these types of problems. If you remember, the picture that we were given had A up here. Let's go back. Let me double check. Yep. Had A up here and then repeating at E. So you had A, you had B, you had C, you had D, and you had E. Drawn perfectly. It's telling me that the t coordinate for B is t sub 1. So this is t sub 1 something, who cares? We actually know what it is, but it's t sub 1. It's telling me that C's x value is t sub 2 something. Okay. Which of the following is true about H? H is positive and increasing. So H stands for height. So first things first, the height of the Ferris wheel is always going to be positive. So you guys are impossible because this says the height's negative. Buddy, you'd be underground and that's a Ferris wheel I don't want to be on. Now, from B to C, H is positive and increasing, or H is positive and decreasing? In this case, I know it's tempting. But you might be thinking, yes, the t value is moving to the right. That's not what I want. The t value might be increasing, but the height, my dear friends, is decreasing, giving us the answer B. Okay. Now, what 2 is asking is describe how the rate of change H is changing on the interval. Whenever you see the rate of change changing, that's concavity talk. Now, this is the same thing. This is the left side of concave up. The left side of concave up is decreasing at an increasing rate. So the rate of change is decreasing at an increasing rate. And that's how they want you to answer that one. All right, so that's the sinusoidal function. Expect something like that on pretty much all the pre-calculus AP exams that I've looked at. There's a bunch of them, and they're very similar for problem 3. So does that mean it's definitely going to look like that on the test? I don't know, but it's worth a shot. So this is what it's going to look like maybe. Hope this helps.